Good evening, all. Thought I'd just give you a bit of an outline of what we've sort of been doing on this. So this is the front axle housing and the front chassis of our trailer. So we have got pieces that are 2700 mil long, going from the back cross member right to the drawbar here. So we're just using a 3.5 tonne 35 mil ball coupling with a handbrake, and then we've just welded a 10 mil plate onto that. Just cut that out of some PFC I had laying around. So a parallel flange channel, for anybody who doesn't know what PFC stands for. And that's attached to 100 by 50 RHS. So it runs up to our first cross member. So these cross members are actually welded onto the chassis across the front there, and then we've got a spacer in it, and then across there. Put a brace underneath that runs the whole distance right through. The only place that I have not welded is under here, across where this section joins onto there. So all we've done is weld it through here. It is welded acrossways, like so, underneath here, so in line with the chassis, but not across it, and that is to try and prevent it from cracking. And then some dirty, great big gussets, just going up and spreading the weight so that we transfer that through, and vice versa around the back. Sorry about the light. And then running to the tail of the cross member. We've got some sections to go in here, and then obviously our spring hangers come from the bottom. Then in the guts of it is where the ball mounts. So we've got some 150 PFC here, again parallel flange channel. And then we've welded a lump of 20 mil flat plate on top of that. So what I've done is I've run 3 fillets, 3-pass fillet right around there, and attached it to the flange of the channel, because this part of it is the weakest part of the channel. This is the strongest on both sides. So the weakest part I wanted to make as strong as possible and transfer the weight to the edges so that it doesn't crack down through here. So 3 passes. So this all becomes the strength, and then it's effectively transferred right down through there. So it's a full-on girder. So that's well welded around, so it's not going anywhere. So this is where we're up to. We're just about to turn it over and start welding some spring hangers on it, and then put some pieces in between those 2 cross members. It doesn't need it, but I just think it's going to look better. So as a result, everything's going well. As I said before, this is our pivot point right here. Our axle actually sits about here. So it's in front of our axle. So the reason why I wanted to do that was I wanted to try and give a little bit more ball weight on this particular trailer, to try and stop the chattering, because if you've only got a drawbar that weighs 35 kilo and you're driving along at 100 k an hour, all it does is chatter. So what I mean by chattering is every bounce you hit, the drawbar bounces, and that's chatter. So I want to try and get away from that. So it's up to 1400 kilo can go on this point legally on this particular front axle. So when we work out that it's so close, well, it's actually within inside the axle frame, but it's just tipping forward. Now, the only reason why I wanted to do that was, yes, ball weight, but the other thing too is that if it was in the centre, there's nothing stopping the drawbar from lifting, and obviously smacking the front of the trailer. So that's rather embarrassing. So yeah, that's what we're going to do. Obviously, we've got to use a wheel, like a jack at the front to hold it. But so this one here, I'm expecting that we'll have probably around about 30 kilo of ball weight. So it's not much, but the whole thing is to try and stop that noise. Just going through the welds with this. all the force is this way. So while it's dragging, the force is going that way. While it's braking, the force is going forwards. So what's actually happening is that the chassis wants to go forwards when it's braking, or the chassis wants to go away from this plate while it's getting towed. So one thing that I've always done is complete overkill, but I just feel comfortable with it. And that is that I've always put a 3-pass fillet on these rather than just a single pass. And the whole purpose is the actual weld thickness through the bottom of the throat down the bottom is approximately 12 mil. So you've got 12 mil of steel on the top of that RHS that's actually attached to that piece. So whereas if you've got a colder single pass, for argument's sake, there's nothing stopping it cracking. So whereas it's actually got to it's got to pull the entire 12 mil section clean out of that RHS, and that is 170 mil long. So transferring our weight or our structure or our strength through the two items is the critical part. Now with plates, I've always worked on the basis that a plate should be pretty much the same thickness as the actual coupling. Now, I'm not worried about the pedestals. So what I mean by the pedestals is the higher parts there, but I'm just worried about the main section. So that is 10 mil. So what I've done is I've created a 10 mil plate. So, and that's what I've sort of done. And obviously the pedestals, they eliminate any warping that you've got in this plate. And the bolts clamp down through onto those pedestals. Some people have been in the past, they use like a lump of 4 mil, maybe even 5 mil. I personally don't like that. I'd like to see some more media material, because this is actually attaching it to the car or the vehicle that's towing it. So we just got to punch some holes when we're ready. When you think about it, there's only 4 bolts holding this. So it gives you a bit of an idea of the strength of bolts. One thing, talking about bolts and what have you, I do prefer on structural things like this, bolts and a spring washer or a washer rather than a nylock. Some of those big 3/4 drive Milwaukee or Makita rattle guns can strip a nylock quicker than they can an actual nut. Another tip is that if you use an imperial bolt rather than a metric bolt, the nuts are actually deeper, so they've got more holding force. But yep, that's just some of the things that I've sort of learnt and I've just put into place. So I'll go through and just explain how I've set this up so that I get it square. Right down there, I just put the cross member in, worked out the centre, then worked out what spacing I wanted between those two cross members. So from this cross member to that cross member, and from memory it's 500 mil, and then I wanted to come down to basically nothing in the middle here. So it's 80 mil at the front. So in order to get that straight, it's near impossible by eye. So what I did was I tacked this chassis rail to the top and then tacked this one. I knew my spacings, so that was fine. I tacked on the inside so that I could actually flex. Then I used a 3-point laser or 3-line laser, something you get from any hardware store. Went across that cross brace at the back. And then if you get that in line across this edge here, the crosshair has to be 90 degrees. So when you come down to here, I've worked out exactly where 90 degrees is. Happy with it. Put another tack on both sides, on the other side, so on the outsides, then I'm happy with it. Everything's good. Come back and remeasure with the light. When I'm really happy, I've just put a tack under here and just welded this, and this keeps everything square and we won't have a problem. One thing I've done is I've tacked on both sides of this 50 underneath. So that just ties it all together. And then off you go and start welding away. So now, just going back to this, the way I've set this up, this is where all our force is going to be. So with our drawbar, we don't want to have a situation where this cross member folds up or breaks. So if it cracks along the chassis here and then starts to fold up. So by putting this brace underneath and then welding it together, it's actually holding it. So it's incredibly strong. There's no way known it's going to move. And then to put the gussets there as well. So the idea is that you build it once, you build it right. It's probably overkill, but I've always done that. And as my mates attest, it's BMT, built McCrohan tough. So, and we like to over-engineer us McCrohans. So yeah, that's the go. Stay tuned, and we're going to turn it over and start welding outer chassis rails on, and we'll put some spring hangers, and then we'll start seeing if we can put it underneath the trailer. Thanks for watching.